Welcome to today's video on specific heat capacity. In particular, we'll be looking at the following equation. Q equals mc delta T, or as my students like to call it, Q equals mcat. Let's look at these quantities. So Q equals the heat transferred in joules. M is the mass in kilograms. C is the specific heat capacity, and it's measured in joules per kilogram per Kelvin. Put simply, it's the amount of energy required to raise 1 kilogram of material by 1 degree Celsius, or indeed 1 Kelvin. And finally, delta T means the change in temperature, and it's measured either in Kelvin or degrees Celsius. Let's look at a handful of examples of how we can use Q equals mc delta T to make some calculations. Okay, in example 1, we want to find out how much energy is required to raise 3 kilograms of metal from 10 degrees Celsius to 18 degrees Celsius. So let's write down what variables we know. Now the specific heat capacity for iron I've looked up on the table to be 450 joules per kilogram per Kelvin. Let's use the following equation. So we find that we've got a mass of 3 kilograms of iron, which changes its temperature by 8 degrees Celsius, and it has a specific heat capacity of 450 joules per kilogram per Kelvin. The amount of heat energy transferred will be 10,800 joules, or in scientific notation, 1.08 by 10 to the 4 joules. Example number 2. Find the amount of heat lost to the surroundings when 2 kilograms of water cools from 80 degrees Celsius to 20 degrees Celsius. Once again, let's write down our variables. Okay, so after the heat transferred, we know the mass of the water is 2 kilograms. We have the specific heat capacity of water as 4,200 joules per kilogram per Kelvin. Now that's given to us from a table. And the change in temperature, it's dropped from 80 to 20, so it's got a change in temperature of 60 degrees Celsius. I'm not too worried about the positive or negative notation on the change in temperature, because in this example I want to know what heat has been lost or transferred to the environment. So I'm just going to use the highest temperature, take the lowest temperature, and change in temperature of 60 degrees Celsius. Let's place it into the equation and solve. Okay, so again, using Q equals mc delta T, we find we have 50.4 kilojoules of energy being transferred when 2 kilograms of water cools by 60 degrees Celsius in the surrounding environment. Example number 3. Find the increase in temperature when a 10 kilogram aluminium bar is heated by 448,500 joules. So in this case, we're after the change in temperature. We have a mass of 10 kilograms. We have a specific heat capacity of 897 joules per kilogram per Kelvin. And we have a heat transfer of 448,500 joules. Our original equation was, we want to transpose this to make delta T the subject. Let's now substitute our values to solve our problem. So we find when a 10 kilogram mass of aluminium is heated by 448,500 joules, that its change in temperature, or its rise in temperature, is 50 degrees Celsius, which can also be expressed in K, as it's only a change in temperature. Example number 4. A student supplies 1.4 by 10 to the 4 joules of energy to 50 grams of oil in a sealed container, and the temperature rises from 10 degrees to 20 degrees Celsius. We're asked to calculate the specific heat capacity of the oil. So in this case, specific heat capacity is the question mark. The mass is 500 grams, but of course this equation uses masses in kilograms, so we must write that 500 grams as 0.5 of a kilogram. The amount of energy was 1.4 by 10 to the 5 joules. And the change in temperature was the oil rising from 10 to 20 degrees Celsius, so the delta T is 10 degrees Celsius. Let's look at our starting equation. Making C the subject. So our oil has a specific heat capacity of 2,800 joules per kilogram per Kelvin.
You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.